Lesson 1.7, Squares and Square Roots. What do we mean when we talk about squares? The shape? Sometimes, but not right now. A square occurs when you multiply a number by itself. For example, 3 times 3 is 3 squared. Squares are denoted with an exponent of 2. 3 times 3 is 3 squared. Exponents are going to be discussed in detail later. For now, know that when you see the small number, that indicates that you multiply the larger number by itself that many times. This small number is known as the exponent. This large number is known as the base. Okay. So, for example, if I see 6 squared, I know that I do 6 times 6, and that will give me 36. When we square a number, the product we get is called a perfect square. The following is a list of the perfect squares that appear most often. 1 squared is 1, 2 squared is 4, 3 squared 9, 4 squared 16, 5 squared 25, 6 squared we just did 36, 7 squared 49, 64, 81, you get the idea. Now you may have noticed something with these last 4. When you have a multiple of 10 or 100 or 1,000, etc., you square the front number, 5. 5 squared is 25, and then you double the zeros. Add 1 0, 2 zeros. That makes squaring large multiples of 10 very simple. This list are the squares between 1 and 25. My highest recommendation is that this list gets memorized. At the very least, you should memorize 1 to 15 and then 20 and 25, but 16 through 19 are important as well. The reason it's important to memorize these squares is because as soon as you have the squares memorized, it makes the process of finding square roots much more simple. A square root of a number is a value that when multiplied by itself gives the number. So if 3 squared is 9, the square root of 9 is 3. Squares and square roots are opposite, just like multiplication and division or addition and subtraction. If we take the square roots of perfect squares, sorry about that. Well, 1 squared was 1, so the square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. 6. Square root of 49 is 7. 8. 9. 10. You get the idea. I've just undone everything that we had done in the previous slide. Squaring and square rooting are opposite. But what happens when we have non-perfect squares? Well, we can still take the number of square roots that are not perfect squares. These are irrational numbers. They give us decimals that never end and never repeat. We talked about irrational numbers earlier in a previous lesson. If we use a calculator, we get an approximate answer because the calculator only has so much room. So for example, if I take the square root of 10 and I plug it into the calculator, I get this big, long string of decimals. Now, it depends on which calculator I'm using. Some calculators have more digits than others. Small calculator may end it here or here, but it'll keep going on forever. It never ends, and as you see, there's no repeating pattern. So we say it's approximately 3.16. I rounded to the hundredths place, and this too kept the 6 the same. If I plug 18 into the calculator, I get 4.24264 and all these numbers. Well, this is approximately 2.24. We can also simplify non-perfect squares using factor trees, which is going to be covered later. For now, you can use your calculator.